Hi everyone, thanks for joining. My name is Craig and I will be covering a few things today. Specifically, what a custom AppID signature is, what they're used for, how to write one, along with a live demo detailing how to design, deploy, and test them. For this tutorial, I'll be using Security Director 17.2R1 and an SRX 1500 running 17.4R1. Also, for those who were not aware, custom AppID support was added in 15.1 X49D40 back in November of 2016. So, what is a custom AppID signature? Custom signatures are usually created to identify traffic which does not match Juniper's existing application signature database. The applications which are not recognized by default are generally listed as unknown or unspecified encrypted within the SRX's traffic logs. It's also important to note that all custom signatures are user-defined, and they consist of one or more patterns which match different attributes of the desired application. AppID contexts, just like IDPs, tell the engine specifically where to look in a stream for a pattern match. As you would expect, limiting the inspection to a particular type of field or header within the stream can dramatically improve the performance of the signature. As an added bonus, context can significantly reduce the learning curve for signature development as well. So if the engine handles the complexity of limiting pattern searches to the user agent header, as an example, it avoids the administrator having to understand the correct bytes, flags, and/or regex involved to do that on their own. As web applications are by far the most common, HTTP contains the vast majority of context available to AppID. I'll avoid going over these one by one in the interest of time. You can pause the video to review if you'd like, but I will note a few important details before moving on. Many of the HTTP contexts are noted as being parsed, which simply means that the pattern you define is applied to the stream after the protocol decoders have been run. This ensures that you, as an administrator, do not have to account for transfer encoding mechanisms like chunking when you're writing your patterns. It's also important to note that only a subset of contexts within JDPI are available to AppID for processing. If, for some reason, you're unable to find a relevant context for your signature, it might be worth evaluating IDP instead, as it has over 600 contexts when compared to AppID's 11. So the remaining two contexts on our list are two of the more popular options for defining custom signatures. SSL server name is a great first context that you can use for defining web applications, especially when you're not using SSL forward proxy on the SRX. And for applications which do not leverage HTTP as their underlying transport, utilizing the stream context allows you to search for patterns in any TCP or UDP stream for a match. It's of course not as efficient as the other contexts, but it does allow for considerable flexibility when defining applications. And of course, we'll end up using this context in our example later on. So again, in the interest of time, I'll try to be brief here as you have the ability to pause the video if necessary. For those of you who are new to signature development, don't be afraid. It's actually pretty straightforward. The goal in signature development is simply to write a pattern that should only be present in the attacker application you're trying to identify. You want to minimize any possibility of overlap with traffic that you're not interested in, of course, avoiding false positives. So to start, often you simply want to search for the longest string present in the stream or context you're trying to match. And also, if possible, adding multiple terms to your signature should increase its fidelity dramatically. And as an added tip, if you're confident that the raw bytes of the pattern you're looking for will not change, you can generally write the most effective signatures by matching them explicitly, just like the example at the bottom of the page. Alright, jumping to the hands-on portion of the video, we'll try to find an unknown application we can write a signature for. So as you can see, we're currently staring at the dashboard screen of Security Director. So we'll first need to start by moving over to the monitoring tab. And then depending on your preference, you can either start in the application visibility view. I would suggest going through grid view, and there's a search function here to identify unknown in case you're looking for that one specifically. However, my recommendation is to go through events and logs and go to app track. And in this case, I've actually prepared a filter for us to show some interesting flows. In this case, we're looking for, unsurprisingly, an unknown application and the source IP of 192.168.0.88. And as you can see, there are many flows here. We can open up one of them, look at the event details, and get some interesting information about the flow that we can use to capture packets. In this case, we of course can see that it's being natted. We know that the protocol ID is 6, so that means it's TCP. And we can use this information to go out and capture those packets, whether you want to do it on the SRX itself or from the client. That's up to you. Again, in the interest of time, I've gone ahead and already captured the traffic we're interested in directly from the SRX itself. And as you'll quickly notice, the application we're looking at is in fact Synergy, which is just a keyboard and mouse sharing application. When looking at TCP applications, it's likely that the most interesting data for signature development is going to be contained, at least partially, within the first data packet of the session, which is packet number 4. And looking at it, we can clearly see the Synergy string is present along with some additional handshake information. And then, looking at packet number 6, which is the first push hack from the client themselves, we can see the same Synergy string is also present. Knowing this, we can develop an accurate signature with very little effort. Moving back to Security Director now, we're going to create a custom signature for Synergy with 2 patterns. One for the first server to client pattern that we saw, and the second for the client to server string that follows. And of course, once complete, we'll be able to add the signature to an application firewall rule and deny the traffic. Now that we're in the actual application signatures page, we simply need to go to create, give our signature a name. In this case, we're going to call it Synergy. Most of the fields here, of course, are optional, but we do need to specify that we're creating a layer 7 signature. We're going to leave cacheable as false. And then we're going to create a layer 7 signature over TCP with 2 terms. We're going to call the signature Synergy Sig1. We're going to leave the port range blank because, of course, we want to be able to identify Synergy on any port, not just 24,800 like we've seen in the logs. The first term will be our server to client, which is packet 4, and we know we can use some simple regex from the slides earlier, defined as Synergy. In this case, we're doing a case-sensitive match. And of course, we're going to add a second term, which will occur after term MO1 has matched, and we know that is client to server. And we're going to use the same pattern as we did earlier. And that's it. We hit OK. After having created our signature, all that's left to do is actually apply it to a security policy. So to start, we need to create a app firewall policy itself. In our case, we're just going to call it Synergy. We're going to add a single rule, which will only drop Synergy, permitting all other layer 7 applications. I'm going to call it drop Synergy, and we're going to simply add our new signature. We can search for Synergy in this case. Apply it, make sure the action is set to deny, hit OK, and make sure the default action for other applications is set to permit, making sure we're not dropping anything else. We hit save, and then we can move to the firewall policy. So diving right into the firewall policy itself, we've got a very simple one set up. It's global, and there's only 3 rules. The first rule, of course, is doing GeoIP blocking. Second rule is just dropping some unwanted traffic. And rule 3 is our permit all. Definitely not best practices, but it works for the purposes of the demo. And it's set up to permit any service, but it does subject the traffic to IPS, UTM, and threat prevention. And to edit this and apply our blocking for Synergy, all we need to do is define an app firewall rule base, in this case, the Synergy one that we just defined, hit OK, hit save, and then update the device. Now that the policy's actually been applied to the SRX, we can go and check within the logging tab to see what's actually happening with Synergy. So going back to the AppTrack logs, hopefully we'll be able to 1, see that Synergy is being identified correctly, and 2, be able to see that Synergy is in fact being dropped by the firewall as per our policy. Just type in application equals Synergy. And we can see that there are some AppTrack session close messages with Synergy being identified, and we can probably assume that it's due to action. So yeah, we can see application failure or action as the reason for session closure. And we would expect to see the packet count equals 6 to match both of our terms. So in our case, we've got packets from client are 4 and packets from server are 2. And that is what we would expect to see for a successful pattern match. So I suppose this concludes the tutorial. I hope it's been helpful for you. Please feel free to leave any questions or concerns in the comments section below. And of course, if there's enough interest, I'll look at creating a second AppID tutorial in the future with more complex signatures. Thank you for watching.